This is section 2.2, considering categorical data. Coming to you on a nice summer day outside before my kids wake up, hopefully before my kids wake up. So let's get moving. Topics to take note on today. We're talking about bar plots and the difference between a bar plot and a histogram. We're also going to talk about how you can have them stacked side by side or standardized. And we're also going to talk about multiple box plots, which are different from bar plots, and also contingency tables. All right. So a contingency table is a table that summarizes the data for two categorical variables called a contingency table. So we're going to show one below that shows the distribution of students' gender, whether or not they're looking for a spouse while in college. So, and this is that, I believe this is another study, probably from Duke University. So we've got looking for a spouse, yes or no on the top. We've got gender, male or female on the left. And this is how the numbers line up. And if you just quickly look at the numbers, you might not have a sense for how things shake out. But we can plot them in a way that kind of gives us an immediate intuition about how the numbers shape up. So we can do a bar plot is a great way to kind of display a single categorical variable. So you can do it by frequency, which we have on the left, or a relative frequency, which we have on the right. So they look identical, but the y-axis is different. One of them is showing you a count, and one of them is showing you a percentage. So how are they different from histograms? Think about it. And the answer is bar plots are used for categorical data, and histograms are used for numerical data. With a bar plot, there's only one way to do it, and you can choose whether you're doing count or frequency. And for a histogram, you can choose all sorts of bin widths. And so there's lots of different choices with a histogram, whereas with a bar plot, there's really no choice. Okay, so is there a relationship between gender and whether the student is looking for a spouse in college? Let's look at the row proportions. So females looking for a spouse, 51 out of 137, because we're dividing by the total number of females. Males looking for a spouse, 18 out of 70, so that's 0.26. So those are different, and yet only 11 percentage points different. So yeah, something we can talk about later. So bar plots with two variables. When you have two variables, you can do different things. You can stack the bar plots. You can do a side-by-side bar plot, or you can do a standardized stacked bar plot. So I'll show you what those mean in a second. So here you've got male and female, and so we can do the stacked is dark blue is no, and light blue is yes. And so we can look here, and then so what's some of the difference you see? Well, in the second one, we're looking at like only the percentages of male and female, but the ones on the left and right, that kind of loses information. It loses the fact that our sample size of male in this case is smaller than our sample size of female. And so the one on the left and the one on the right give both of those things. And personally, I like the one on the right, which is called mosaic plot. It's a great way to kind of sense proportions, but also the difference between the proportions, as well as the difference between the sample sizes. All right, well, the differences between the two visualizations shown below. So here we have something with something to do with the disease, and we're looking at the survival of it. And so we're looking at relative frequency, adult versus child, adult versus child. So think about it. What are some differences of the two visualizations below? Well, there's one dimension that the one on the left is not showing, and it's not showing that our sample size of children is much smaller than our sample size of adults. Okay, so that's kind of how the mosaic plot is able to give us the full information, whereas the relative frequency doesn't always do that. Pie charts. This is the only pie chart you will see in this class because pie charts are not good. They did a study where they gave people like a bunch of unlabeled things like this, and people are the worst at guessing the numbers on pie charts. So don't use them, okay? That's one time we're going to talk about. All right, comparing numerical data across groups. Put my coffee down. All right, does there appear to be a relationship between the class year and the number of clubs students are in? So here we have first years, sophomores, juniors, and seniors. And it seems like our sample size is small. And I can tell that just by the, well, maybe not. It's hard to, I guess I don't know that. Never mind. I just was guessing that because how the median, the black line, kind of jumps between 2 and 3, but it makes sense because that's the median. And it would be either like 2 or 3 or 2.5. Okay. But also the number of outliers that we have for sophomore and junior is not very small, or it is small. And so do we notice any trend here? It seems there are first years who have 0 clubs, and that's sort of an outlier for junior, sophomore, and junior, and there are no seniors with 0 clubs. So that's maybe a trend we could see, but otherwise, the biggest trend is that they're mostly the same. All right, now let's talk about Florence Nightingale. Florence Nightingale, one of my personal heroes. She was a rich, well-educated British woman who felt God calling her to help others. So in defiance of her parents who wanted her to get married and raise a family, she served as a nurse in several wars. She was well-educated and a very good writer and mathematician, and she used these talents to write back home to advocate for better conditions for the wounded. So she was doing this before like germ theory, before we knew that it was germs that caused disease. And she basically, through her advocacy, made the British Army do a lot better at providing like hospitals and medical treatment for soldiers. This is an actual diagram she used where she was looking at the causes of death of the British soldiers in the Crimean War. And so she was using, so the gray is soldiers dying from health stuff, which we would think of as being preventable. And so you see that majority of the British soldiers are not dying in battle, they're dying from disease and their wounds. And through this plot, like in doing it this way, she was able to advocate for better conditions for the soldiers. And that is the end of section 2.2.